Previously, we've talked about graphing lines, or graphing the solution sets to equations in the form y equals mx plus b, or something equivalent to y equals mx plus b. In this video, I'm going to go through a few problems where we're using this technique of graphing to solve systems of linear equations. So let's start with that word systems. What does that mean? Well, in algebra, we say systems, and what we mean is lists. So basically, a system of equations is a list of two or more equations. And in this case, they're linear equations, so the graphs of each equation is going to be a straight line. All right, so what does it mean to solve a system of equations? Well, we know what a solution is to a single equation. It's an ordered pair that makes that equation a true statement. And the connection between the equation and its graph is that every individual solution, every individual answer, is a point on the graph. And since one equation has infinitely many solutions, that means there's infinitely many points on the graph, and those infinitely many points, they form that line. And that line is basically a picture of the solutions. We're basically drawing a picture of the answers when we make a graph, of an equation. So for a solution to work for the entire system, it has to work for each equation in the system. So we're basically, by using graphing to solve the system, we're looking for a point. Remember, points are solutions. We're looking for a point that's on both graphs. And since these two graphs are each going to be a straight line, we're looking for the one point where those two lines cross, or those two lines intersect. All right, so let's graph these lines, and let's use the methods that we've been using previously. Solve for y. Rearrange the equation so it's in y equals mx plus b form. Okay, so we could start off by subtracting 3x from both sides. So those 3x's will cancel. On the left, we have a negative 2y is equal to negative 3x minus 4. And to solve for y, we need to get rid of the minus 2, so divide both sides of the equation by a minus 2. So on the left, those minus 2's will cancel, and we have y equals. On the right, those negative signs cancel each other out, so we have positive 3 over 2x plus 2. So by solving for y, we've identified the slope and the y-intercept. Since the y-intercept is 2, we know that the point 0, 2 is on the graph. So let's put that point over here. And we also know the slope. The slope is 3 over 2. And a point and a slope, that's enough information to graph the line. And so the slope is 3 over 2, so we go up 3 units over 2 units. And those 2 points give us the line. So let's draw a straight line, or as straight as I can make it, through those points. All right, and we'll do the same thing with the second equation. Solve for y. So we could add 1/2 x to both sides, plus 1/2 x. So that will cancel off the x's on the left. So we will have y equals 1/2 x plus 6. So again, we've identified the slope and the y-intercept. So we have the point 0, 6, because 6 is the y-intercept. And we have a slope of 1 over 2. Okay, so let's graph that second line. We'll start at the y-intercept because that's a specific point we know. And the slope is 1/2, so up 1 over 2. All right, and so there's our second line. And we see that these two lines intersect at a point. And that point, that looks like 4 on the x-axis and 8 on the y-axis. So that point of intersection, 4, 8, is the solution to our system. So we're going to give this solution as an ordered pair. So the solution is 4, 8. When x is 4 and y is 8, both equations are true. Okay, so if you look at the directions, you see state the solution as either an ordered pair, which we just did, or we have these two other special cases, if there's no solution and infinitely many solutions. So we'll talk about when both of those occur. All right, so let's move on to problem number 2. All the problems are going to be the same on this video. Given two equations, solve the system by graphing. Okay, so we'll proceed always the same way. Graph each individual equation by solving for y and using the slope and the y-intercept. Okay, so we could subtract 3x from both sides. So the 3x's will cancel on the left, and we'll have 2/3 y equals negative 3x plus 5. And we have to solve for y, so to get rid of the 2/3, we can multiply by the reciprocal. Multiply both sides by 3 over 2. Okay, that'll cancel off these fractions on the right. The 3's cancel, the 2's cancel, and we have y equals. And on the right-hand side, we'll multiply each term by 3 over 2. So negative 3 times 3 over 2, that's negative 9 over 2. Negative 9 over 2x plus 5 times 3 over 2. So that's 5 times 3 is 15. 15 over 2. Okay, so we've identified the slope and the y-intercept. So we have the point 0, comma 15 over 2, and we have a slope of negative 9 over 2. So we can now graph that line. So let's look at the second line. Again, solve for y. So we could add 18x to both sides. That will cancel off that 18x on the left. And we'll bring down the negative 4y, which is equal to 18x minus 30. Okay, now to solve for y, let's get rid of the negative 4. So we'll divide both sides by negative 4. And we have y equals. Those negative 4's will cancel. So we have y equals, well, 18 over negative 4. Well, 18 over 4, they're both divisible by 2. So that reduces to 9 over 2. And there's a negative sign. So negative 9 over 2x. Two negatives make a positive, so that's plus 30 over 4. Again, both divisible by 2, so that becomes 15 over 2. So we see we have the exact same line, the same y-intercept, negative 15 over 2, and the same slope, negative 9 over 2. So it turns out what looked like two different equations with two different graphs, once we solve for y, we get the same line. So without even graphing, we know there are infinitely many solutions. And the reason we know this is because these two lines basically overlap. So if I'll graph the one on the left in blue, so 0, comma 15 over 2. 15 over 2 is 7.5, so we'll go to about right there, 7.5, and a slope of negative 9 over 2. So down 9, and then to the right 2 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 9 over 2. All right, so there's our line. So we could draw a straight line, or as straight as we can make it, through those 2 points. And that second line is same y-intercept, same slope. So these two lines basically overlap each other. So every single point is a point of intersection. Infinitely many points mean infinitely many solutions. So that is the special case where there are infinitely many solutions. All right, let's look at number 3. Again, we have two lines to graph, so let's solve for y. Subtract 5x from both sides. That will cancel the 5x's. Negative 30y, we bring that down, is equal to negative 5x plus 8. And divide by negative 30 so we could solve for y, get y by itself. So those negative 30s will cancel, and we have y equals 5 over 30. That reduces to 1 over 6, and the negative signs cancel, so 1 over 6x minus, because we have 1 plus and 1 minus, 8 over 30, which reduces to 4 over 15. So again, by solving for y, we've identified the slope and the y-intercept. So we have the point 0, comma, negative 4 over 15, and a slope of 1 over 6. Now, if we look at the second equation, do the same thing. Solve for y. So we could subtract 1/2 x from both sides. That'll cancel the 1/2 x's, and we'll bring down the minus 3y, which is equal to minus 1/2 x plus 10. And to get y by itself, we'll divide both sides by negative 3. All right, so those negative 3's cancel, and we've solved for y. We have y equals, well, negative 1/2 divided by negative 3. The negatives cancel, and that gives us positive 1 over 6. And then we have a minus 10 over, 1 over 6x minus 10 over 3. So again, we've identified the slope and the y-intercept. The y-intercept is negative 10 over 3 with a slope of 1 over 6. So we see these two lines have the exact same slope, but they have different y-intercepts. So before we even graph them, we could see that this system has no solution. And it has no solution because these two lines are parallel. If we graph the first one, a y-intercept of negative 4 over 15, that's somewhere between 0 and negative 1, so somewhere in there, with a slope of 1 over 6. So up 1 over 6. So our second point is about right there. Okay, so that's the line on the left. And on the right, let's graph it in a different color. Let's use red. Y-intercepts of, I forgot the 0 in there. There's actually a 0, comma. Don't forget the 0. 0, comma, negative 10 thirds. So negative 10 thirds is a little bit more negative than negative 3. So 1, 2, 3, so maybe about right there. Again, a slope of 1 over 6. So up 1 over 6. So you see we get these, that's close to that point. There we go. Parallel lines. Since these parallel lines never meet, there are no points of intersection. There's no point that is on both lines. Remember, a solution is where the lines intersect. So this is a situation where we have no solution. Okay, so those are the three possible scenarios. Let me scroll back up. So most of the time, this is what's going to happen. Two lines intersecting at one point, there's one solution. So in this case, our solution was a single ordered pair. And the two special cases of no solution or infinitely many solutions occur when you have the same line. Both equations give you that same line, so they overlap everywhere, so there's infinitely many solutions. Or the third, or the other special case, is when you have two lines that are parallel, so they never meet. In that case, there are no solutions. All right, so that does it for the three possible scenarios. When you're solving a system of equation, there could be one solution, which is what normally happens, or there could be no solutions or infinitely many solutions. Now let's just look at one more quick example. See, in this case, we have a vertical line and a horizontal line. So for the one on the left, to solve for x, we can multiply both sides by 3. So we'll have x equals 6. So that's the line that crosses the x-axis at x equals 6. We talked about vertical lines and horizontal lines in the last unit. And then same thing, we could solve for y. So divide by 3, and we get the line y equals negative 10 over 3. So negative 10 over 3, let's say this is the blue line, this is the red line. And so negative 10 over 3, again, that's a little more negative than negative 3. 1, 2, 3, so maybe about right there. So one horizontal line and one vertical line will always meet at one point. And in this case, it's when the x value is 6 and the y value is negative 10 over 3. And this is again another example where the solution is an ordered pair. All right, that does it for this video. Remember, when you're solving a system of equations, whether you're using this method by graphing or one of the other methods that we're going to cover, there's only three possibilities. There is one single solution, there are no solutions, or there are infinitely many solutions. All right, that does it for this video. I hope it was helpful.